So can you all see my screen?
No, ma'am.
No.
Yes, ma'am.
Yes, ma'am.
Okay, okay.
Now it's visible, ma'am.
Okay, okay. Maybe network is slow. It might take a little bit time. So yeah, today we will discuss about asymptotic notation. So brief review. Last time we discussed about times complexity and space complexity. It's like okay. So last time we mainly discussed about space complexity. What is space complexity? Who wants to tell? What is space
Space
complexity?
complexity is ma'am, space complexity is the memory requirement.
Okay. Then time complexity.
Time complexity is the performance requirement.
Performance in what terms?
Performance in
Time required to complete execution of the program. Okay.
hmm.
Performance analysis will be done once you get how long it takes to finish a program. Okay. So
Hmm.
space complexity, if you guys remember, it can be defined as auxiliary space and input space. Last time I also mentioned you have to count all those things that we normally use in program, like variables, then all the constant values, temporary variables, then you have to count each of the program instructions, then the execution. So auxiliary space means it's like the extra space or just like temporary variables you use, those are your auxiliary space. And input space is the input you will provide. So suppose for this particular algorithm, this is the same example I gave last time. So anyone can tell what is 1 here and how come we get 3 for this algorithm?
Ma'am,
Come we get these.
One
A,
is
ma'am,
integer and
A is 1 and B is
B is
2 and
character.
C is 3.
Why this term 1 and why this term 3 comes? Any guesses? Okay. See, we have 3
One
variables.
is
Oh, okay, okay. Someone
integer
asked.
and three is character.
No. Okay. This one is very simple one. Okay. We have 3 variables C, A, and B. Correct? So for 3 variables, the 3 is here. Then we have one constant term. So this one is for 10. So as I mentioned before, you have to consider all the variables plus constants or any execution time. Or so here 3 will be for 3 variables A, B and C, and 10 is for constants. Now this one is the simple one. Then space depends on the data type of given variable and constant type. So it will be multiplied accordingly. So for this, you need to remember this table. I guess you guys already know what type of data type takes how much space, right? For boolean and character, these are the basic one. They take 1 byte, then short takes 2 bytes, then float and int 4 bytes, and double long 8 bytes. Normally, we mostly deal with int, double character, and long, right? So next, any guesses for this one? Any guesses? So what will be the memory requirement for this particular piece of code? Just think for a while then answer. Just remember this table as well. You need to calculate, okay? Take pen and paper with you. It will be easier for you guys to understand. So see this one, take some time and calculate and tell me.
12 bytes.
We have how many variables here?
4 variables.
4 variables. So
Variable.
4. 16 bytes.
just tell me the total one. You remember we have 4
4.
variables, then each variable is of type int. Then it takes again 4 bytes. Now calculate and remember there will be an extra space for this return jet as well. Just calculate and think. I'm just telling you there are 4 variables and uh, each int type variables take 4 bytes.
What? Fourth character.
These are variables and these are integer type, right? In the table
Yes,
I
20
ma'am.
have
bytes.
mentioned int takes 4 bytes.
Okay, okay.
Okay. Now
20
just
bytes.
calculate.
20.
I INT
Calculate then tell me.
INT take 1 byte, no? INT very
No, it's 4 bytes. I told you int takes 4 bytes.
okay, 4 byte. Okay, okay. INT 4 byte.
4 bytes, ma'am, answer.
No, answer is not 4 bytes. It depends on number of variables, then space required by each variable according to its data type.
Ma'am, 20 bytes. 20.
Okay, someone says 20 bytes, then others
Ma'am, 12 byte.
12 bytes, then
Ma'am, 16 bytes.
what did you say? Minus? Someone said minus something byte?
No, ma'am.
And since all the 4 variables, we have to assign memory and also for one memory for return value.
Yes,
So it's
yes,
20 bytes.
20 bytes. Okay. Anyone else want to say or try? So it's correct. It's 20 bytes. So there are 4 variables A, B, C, and Z, and all are of integer types. So 4 into 4. Then additional 4 bytes is required for your return value, and return is also in. So 4 into 4 plus 4 equal to 20.
20 bytes.
So now try this one. This is a bit difficult, but just remember the rules. You have to check all the instructions inside your function. So for now, just this one you can just ignore. Just see these lines. Okay. Each of the instructions, all the variables, and each type will take how many bytes. Just type for a while. Write it down. You guys understood it, right? how many variables we have? Just think about that. And what are the types? There is another hint that
What
for
is
your
the
array, the length will
n is
be n
so
because
n is the length of the array, no?
yes, yes, n is the length of the array.
And it
So
may then it may vary depending upon the value of n.
yes,
So
that's correct. For the time being, you just take n as n.
variable
Okay? For
for
this particular statement, n will be there.
also.
And will be
And
There.
memory required for the value will be 12, and since it is in so 4, and it will depend upon the number of n's. So I'm 4 into n and plus 12.
Okay, then others just wait.
Ma'am, what will ma'am? Hello, can you hear me?
Yes, I can hear you.
Ma'am, what will the value of n?
For the time being, just keep as n. N will depend on the length you will get. Right?
Situation
Yeah,
on the condition.
yeah. Just keep n as n.
Okay, ma'am. Then I plus plus. Then it means like we'll put one on the place of I. Then
See how many variables we have.
Variables is 4. I'm actually for the
Other
return
than
value
ma'am,
we
array,
we
have
just
to
have to
other than array, because for your array is also in type, right? So
yes, ma'am.
4
yes,
bytes is space. Then again, it will depend on the number of variables, that is n. So memory required by your array in type of array will be 4n bytes. 4 into n. So depending on the size of the array, you can calculate, right? Here I haven't mentioned. So
How four?
how 4? Because your array is of
Mm,
type int. See, it's a int
mm,
variable. Integer takes
INT.
4 bytes.
so,
Okay,
so
ma'am.
ma'am, we have to plus the
Okay.
variables, then multiply the int number with the array number.
Yes, like int number and how many space it takes. Suppose for int array, you just keep it separately. Okay, just see the answer. 4n bytes for your array A. Why?
Array.
Because
Okay.
4 is int type
4
int.
by 4
4
H.
bytes
X
and
and I.
depending on your
Okay.
size, then 4 bytes each for x and I. Okay, you have three other variables x, n, and I. Okay, then we again have
And
return
then
value.
another have return X. Okay, ma'am. Okay,
Yes.
ma'am. I got it, ma'am.
So total 4. So each of them will take 4
4
bytes.
and plus
4
16.
into
Okay, ma'am.
4, 16. Then you need to this plus the 4n portion.
4 and
So total memory requirement will be 4n plus 16.
4 and plus 16.
So whenever you will assign some size to the array, that value will be replaced by n. Suppose your array size is 10. So it will be 4 into 10 plus 16. If your
Oh,
array
okay, okay,
size
ma'am.
is 2, then it will be 4 into 2 plus 16. Okay, you got it? Just see for a
Yes,
while,
ma'am.
think about it, and let me know if you understood or not. So if You understood that thing, right? If I initialize the array size like 10, then your n will be 10. Then size of
10,
the array will be
4 into 10,
4 into
4
10.
into 10, 40, 40,
40 plus
56
50. So here it's just depending on the array size.
array size. So we have to keep it like n only. If we don't have the condition applied there, we have to keep only n.
No, it's the memory required. That means you have to consider all the variables, all the
Ev-
data types. It's not the type complexity. I am not going there yet. I'll go there, but this one is space complexity, you can say. So this is how
Okay.
you
Ma'am,
calculate space complexity. Space means you have to check all the variables that you have used in your program. Then you have to also check what are the data types of your variables. Then if you have return type, you have to take extra value for that. Again, if you use some temporary variables, then also, again you have to count that thing also. Mainly we use temporary variables for swapping, right? So in case of a swapping program, then you need to count the temporary variable as well. So all of you got
Okay.
it right? How we can calculate space complexity or memory requirement?
ma'am, can you explain how we got the 16 again, ma'am, from x equal to x plus a?
Which one? This x equal to x plus ai. See, this one, what is it
Yes,
doing?
ma'am.
This program is for what? Can you understand?
This, yes, ma'am.
So what is it doing? What is code doing? Yeah.
Ma'am, looping.
Looping for what? It is looping. What is it actually doing? Yeah.
It's increasing the value of x.
Okay. So by increasing the value of x, what is it doing? What's the purpose of a here?
A is the array.
Yes. So that means what is it doing? Increasing value of x means it's simply what was the program here?
So
In this program, what was it doing? Sum of,
it was addition, a and b.
yes, so it was calculating sum of two variables, right?
Mm,
Addition of two variables, and that variable then they again added 10, then stored in C. So here, what is it doing? It just adding all the values in your array. It's sum of n numbers in your array. I guess in PPS you did this one before. This is a very simplistic program. Wait, like someone is at the door. Here, class class. Ah, ah, ah.
हेलो आवाज आ रही है या फिर मेरा नेटवर्क खराब है? हेलो
तो तेरी आवाज बहुत वो आ रहा है।
Okay, sorry for the interruption. Someone has requested the word. Okay,
इट्स
so
ओके
what this piece of code doing? It just summing up all the values in your array. So initializing x, then for I, this is for your index. So from 0, it will just adding up each value in your array. You got it right?
It's storing the value in the array.
Yes, it's adding up all the values. It's already written sum. See, sum of,
Oh yes, ma'am.
so it's doing what? Summation of all the n values in your array A. It's taking the array, then also taking the input from the user and adding up the values. All of you got what? How we calculate the space complexity or memory requirement? You need to just go through all the variables you have used, then see what are the data types of those variables, and if there is any constant is used, that will be added to, like in the previous one. Then if you have return type, then again you need to add up that one.
You have to add.
Okay, so I'm moving on to the time complexity one. Okay, so what is asymptotic notation? Asymptotic notations are the mathematical notations used to describe running time of an algorithm. So this is also mainly based on input size. Okay, anyone want to tell why time complexity is more important than space complexity?
because it shows the efficiency of the program, and
Yeah,
the fast the faster the program is executed, the more better the program is.
yes, that's true. See, for any problem, we can have like n numbers of solutions. If I give you a problem, like just now we took one example, like calculating some of the only numbers in your array. So I just took one algorithm, then others can just give me another solution, right? So there can be n number of solution for one particular problem. Now question is you have to understand from all those solutions which one will be more efficient. Efficient means which one will take less time because it's all about timing now. If you are a bit late, then you are late or your time is gone. So that's why we always go for the time complexity one. Space complexity we do calculate, it is also very important. But nowadays the hardware requirements is already like they are already providing us lots of memory. So sometimes we just don't care about the space complexity. But in many cases it's important too. So in this subject, whenever we are going to implement any algorithm, we need to check both the space complexity as well as the time complexity. Okay. So asymptotic notations are what? They are just mathematical notations describe running time in terms of your uh, input value. So what these things do, notations do, they just put some boundary values. Like for example, it can say your running time should not be more than 15 minutes, for example. Okay, 15 minutes, I'm just saying too much time. This maximum time is 15 minutes. Okay, then there can be lower bound too, like it should take at least 2 second time. Okay, so that means I'm bounding the time. Right, I'm giving a time limit like your running time should be from 2 to 5, 2 seconds to 5 seconds, suppose. Or you can say 2 minutes to 5 minutes. Okay, so that's the bounding. So why we do that? because we don't want our program to run for infinite time, right? So even when it goes in infinite loop, we cannot like wait for whole time. Therefore, we always try to give a bound in those time limits. Then those notations are like mathematical notations and it's easier for us to understanding any running time. Okay. So there are three asymptotic notations: big O, omega, and theta. Let's go for the big O notation. So big O notation, it provides you the upper bound of the running time. And big O is mainly used for calculating worst case complexity. See, in most of the algorithm or programming, we only care about worst case complexity. Anyone can guess why is it? Why we only care for worst case most of the time? Any guesses? Why we mostly care for worst case?
And because
I'll come to the graph part later. Just tell me or your guess. Just think about it. Why we mainly care about worst case?
and because we need to know time required and will it finish on time or not the program.
Sorry, I couldn't hear you properly.
Ma'am, because we need to know the worst case scenario because ma'am, we are involving time in the program and we need to be guaranteed that the program will finish on time.
Okay, can you remember what was the worst case? I already mentioned about the best case, worst case, and the average case, right? So tell me what was worst case.
Ma'am, actually, the roast case, roasted because algorithm to take the maximum amount of time to finish. No,
Yes, correct. That's correct. See, all the time I already mentioned all your space complexity, time complexity mainly depends on your input size. Now, depending on your program or algorithm, your input size can vary, right? So all of the
yes, ma'am.
program's time complexity will mainly depends on your input size. If you provide high input size, then time will be more. So what is worst case? Why worst case? Because it calculates the maximum time taken for
Amount
any
of
size. Yes, exactly what you said. It calculates the maximum time taken by any input size. Therefore, we always consider the worst case complexity. So big O notation calculates the worst case. So big O notation you can define using this equation. You can say big O of a function Gn is equal to another function Fn such that there exists positive constant C and N naught such that Fn is less than equal to a constant into Gn and also greater than 0. So your function Fn should lie between 0 to your upper bound Gn. There is another C is there. So your constant means there will be cost for each of the execution of the line, right? So C you can say it's like a constant. So this C part will remain same and your Gn function will keep changing according to your program. So you always have to remember these equations of big O, omega, and theta. So just simply remember big O is the upper bound. You just remember this graph. So upper up, if it gives upper bound, that means your CGN will be upside and your FN will be just below your CGN graph. So suppose here two algorithms are there. This is like genuine case. This one should be the actual one. For example, just think about an algorithm. I am giving you a problem, and the problem is taking time, and you can represent with this curve CGA. Then that problem you are solving using another algorithm, and the predicted value is somehow Fn. So your actual one is like a boundary, it cannot go beyond this. So your Fn function, whatever solution you give, it should always in the range CGN to 0. It should not go up. Okay, it just gives the upper bound. Anyways, worst case calculates the maximum time, right? In maximum time also we give a upper bound that beyond this portion it cannot go. So your Fn will always under your CGN function. Then next comes omega. Omega notation is the lower bound. So it's the best case. Anyone remember what was the best case? Best case.
Best case is when we get our desired element or algorithms behavior in optimal conditions.
Not okay. When you said optimal, what do you mean? Means what will be the optimal solution, the best solution for any algorithm? For example, I am giving you a searching algorithm. I am asking you to search a particular item. What will be the best case?
And the best case will be when the particular
Minimum amount of
search
size taken for to define the n.
Yes, that's true. Take minimum amount of
Uh,
time. The best case will be if I'm asking you to search a particular item, the item is at the top of the list. Okay? Suppose step
yes,
suppose in the array it will go one by one, right? In a
yes,
array of 10, 10 size 10, suppose it has like 1 to 10 numbers. If I ask you to find the number, tell me the location of number 1, that it will be the first place itself. So that's the best case. You no need to search for the whole array at all, because at the first attempt itself you found your particular item's location. Now, in the same array 10, if I'm asking you to find the location of 10, that means what? It is at the last position in your array. That means you have to go through all the numbers inside the array, right? So, in general, searching, what will be the time complexity for base case? Just guess. I'll go to linear search and binary search later on. But if you want to just think about it, what will be the base case for linear search if you find the item in just one? Just forget about the variables and all. Anyone can guess? It's okay if you cannot. I'll explain later. I just want to see if anyone can guess. Okay, I just keep it as a no. So we'll go to that part later. For the time being, just
maybe
see the
ro-
best.
uh,
Okay, you want to say something?
from the roast case is um, the ro- uh, what was question, ma'am?
I was asking what will be the best case for your linear search if you find the item at the first position.
Ma'am, the roast case, but when
Best.
only when the value is not in the list, no?
Yeah,
Only when
worst. Yeah,
the
worst case can be in two conditions. Either your item is not in the array or list at all, or it is in the last position. Just consider it
yeah.
is in the last position. It is in the array. If forget about the worst case, what will be the best case?
And the value, when the value is equal and to the first element of the list, then we use best.
Only
Okay,
element
okay,
in the
okay, okay. I'll go to that part later on when we will discuss linear search and binary search. For the timing, just
Yes, ma'am.
stay here. So this omega notation will mainly provide you the best case and it will give you the lower bound. An equation for omega notation will be omega of a function gn is equal to f of n such that there exists positive constant c and n naught such that cgn is less than equal to f of n for all n greater than equal to n naught. So again you see the graph, there will be some n naught and n. So n will be always greater than your constant value n naught and fn will be always top of your cgn value because cgn is giving you lower bound, means the least it can take time, means suppose your programming time should take at least 2 minutes, so this 2 minutes will be your lower bound. So program should take above 2 minutes, so your f of n is the running time of your algorithm and it will always will be above your cgn. So big O, what happens? Fn is below your CGN graph and omega O n, big omega, Fn is above CGN. Okay. Initially it will be a bit confusing, but once we go through it, it will be easier to remember. Just remember the graph. So next is your theta notation. Theta notation is for your average case. So it will provide both the upper bound and the lower bound. So if I'm telling your running time should be in between 2 minutes to 5 minutes, that means I'm giving you both the upper bound and the lower bound. So for this theta notation, your fn function will lie in between gn function and both will have different constants. So theta gn we can express like this. Big theta of gn is equal to function fn such that there exist two positive constants like c1 and c2 and there will be n not 2 such that fn will lie between c1 gn and c2 gn, okay, for all n greater than n naught. So you got it. For the average case, for example, suppose I'm asking you to find a value just which is in the middle of your array. That will be your average case. By going half part of your array, you don't need to go further because you found your element. So this is the average case. So always remember big O for the worst case, then big omega is for the best case, and theta notation is for average case. But as I already mentioned, we mostly care about worst case. So for most of the algorithms, we are going to calculate the worst case complexity. And even in questions, when they ask question, when say time complexity, just asking you the time complexity of an algorithm, just give them the answer, the worst case, like big O. Okay. Any doubt about these three notations? I'll show you how to
No, ma'am.
calculate time complexity. I'm just asking about the notations.
No, ma'am. No doubt.
No, ma'am.
Okay, so big O for worst case, big omega for best case, theta is for average case. Always remember that. Big O will give upper bound, big omega give lower bound, and theta will be range of lower bound and upper bound. Now, apart from these three, there are three other notations as well, and those are like small theta, small omega, and small o. And those gives mainly tight bounds. Okay, but for those three, I will not go to that part because those whole design and algorithm work will be covered in your next semester. Design and analysis algorithm, that's a whole subject. You have a whole subject in this thing. So that one is a bit difficult subject, but don't worry, you will get through that too. So for this data structure and thing, algorithm part, we will only concentrate about three notation, all the big one, not going for the small one. So let's see why time complexity is important. Actually, I already mentioned about this. Someone also mentioned also. So for any defined problem, like we have n numbers of solutions. For here example, you can see find a square of a number. I'm just typing it two times. Just find a square of a number. So you can provide two algorithms. One algorithm is you are just counting from 1 to n, then you are just adding the values and storing it n again. And then there's another algorithm which is just giving directly square, means multiplication of two numbers. So according to you, just think which will be more efficient algorithm. According to you, which one will be efficient, algorithm 1 or 2? This meeting got unlocked. Okay, it's going to end soon.
Ma'am, algorithm 2,
Algorithm
maybe.
2. Okay. Why is it 2?
Ma'am, because for square, no, we need the value n, like n into n.
Okay. So in algorithm 1, what we are doing, we are having like 3 steps. We are taking loops, then and then again. So obviously it's going to take more time and as well as space as well.
More space.
Yeah, both time and space because it's looping. So your timing and space will mainly depend on the number of n. Okay, it's not like input independent. More steps means more space and more time. And in algo 2, it's just simply adding the values. So irrespective of your input size or input type, it will just simply add, multiply two numbers and will return you. Got it?
Yes,
Mhm.
ma'am.
Okay. It has only 5 minutes. You want me to continue or I can continue how to calculate time complexity next class. Anyway, it's going to end actually. There are certain steps. Maybe I should continue next class, right?
Yes, ma'am.
Today just think how I calculated the space complexity, then what are the big O theta. So next class I'll show how we can calculate time complexity and we'll also see at least the linear search and it will be easier for you guys to understand.
Yes, ma'am.
Okay? So
PPT
Okay, ma'am.
in
So,
group.
ma'am, in next class we will. Oh,
next class I
hello, ma'am.
will
Can you
show.
hear me?
Yeah, yeah,
Can you hear me,
yes.
ma'am? So linear search and binary search for next class.
First I'll tell you how you can calculate a time complexity. Okay? So after
Oh, okay, ma'am.
time complexity, how to calculate, we will move to the linear search and binary search. Okay?
Yes, ma'am.
Okay.
Ma'am, can you share the PPT in the group?
Okay, yeah, sure. I'll do that.
Okay.
Okay.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Okay.
Thank you, ma'am.
Okay. Angelo Eru. I, it came host. I'm
ঠিক
starting.
আছে, ma'am.